of the key aspects of server-client systems that are cited as being an advantage over more decentralized systems is security. So with server-client systems, you have sort of centralized access, and that allows you to kind of manage all in one place things like users and permissions and various accesses to resources. So that definitely can lead to some security benefits. However, it also can lead to bottlenecks and a single point of failure. And that's something that can definitely have catastrophic consequences, as we'll see in further slides. So one way to combat the vulnerability that comes along with having a single point of failure, like in systems such as a server-client system, is redundancy. And that means having backups of everything from hardware to data so that you can recover in the event of a catastrophic failure or in the event of a threat. One way to measure this is in terms of availability. So we can think of availability as being the result of uptime divided by the total of uptime and downtime together. So of all of the time that the server was running, how much of that was it up? And that can be thought of as the availability. In that case, you would want to improve the availability, and as you can see just from the mathematics, one way to do that is to reduce the downtime. So how do you reduce the downtime? Well, you can certainly do that with redundancy. And if you have good redundancy measures in place, your system downtime is only dependent on how fast you can detect and switch over to a backup unit during the course of some kind of catastrophic failure. So definitely provides some advantages and some safety net, as opposed to not having any redundant systems in place, in which your downtime could be as long as it takes you to investigate and identify the issue, troubleshoot that issue, mitigate whatever effects maybe resulting from that issue, and that could take anywhere from hours to weeks. So definitely some safety and security advantages with redundancy. Another aspect to consider in terms of just overall resiliency is scalability. So how fast can your systems respond to demand, or can they respond to demand at all? It's defined by IBM as the ability, rather, of a system to take advantage of additional resources like database servers, processes, memory, and disk space. So when you have exceptionally high demand, operations could be limited by resource constraints. So if you have a server, capable of responding to, a certain number of calls or whatever the case may be, when you have a spike in demand, it's going to struggle to keep up. And so do you have backups of these hardware and systems and data so that you can scale up your operations when demand is high, and then scale them back down when demand is low, so you can conserve resources and energy. One example of this was the recent Taylor Swift Ticketmaster fiasco, which was caused when due to unprecedented demand on the system with the popularity of Taylor Swift, the pop artist, and a tour that she's currently on, or at least was on at the time. The Ticketmaster system was overwhelmed by all of the users trying to get tickets, and ultimately crashed, leaving a lot of disappointed and frankly angry users, and a whole mess of bad PR in the wake. And again, this is just simply a matter of scalability. These are foreseeable problems, and by putting systems in place that can respond to exceptionally high demand, you can mitigate it. You can scale up, take advantage of additional resources to respond to that extra demand when it's necessary. So two different terms that you often hear when it comes to web-based database systems and this sort of server-client architecture are front-end versus back-end. The front end, these are things that users will see. The front end is often thought of as the user's device. It's the sort of the client in the equation. And the front end is information that users will interact with, or resources, again, that users will see. So that's things like websites, applications on a variety of different devices, These are all what's sort of displayed as the front end. It's sort of the front-facing part of a database system. And on the back end, you typically have the sort of nuts and bolts. These are the things that users won't see, but that make the application run. So the back end is where data is stored. It's where it's processed, either in databases. Data can be either gathered or sent through API calls. And you've got a number of programming languages and frameworks on the back end that can sort of help and facilitate with that the development of software and applications that run the back end. So one popular front-end client-side scripting language would be JavaScript. And JavaScript is just a way to, again, organize and process data on the front end. You can certainly use it to manipulate web page content, everything from drawing graphics to interacting with devices and browsers through various APIs. A lot of convenience, and it's actually quite a powerful tool for again, just organizing and preparing data on the front end for presentation to the user. One application could potentially be form validation. So for instance, you may use JavaScript to check a particular form entry to make sure that it would be accepted by the database, or that it's safe to and secure to present to a database, so that it's a valid entry. And typically, with form validation, you want to do that both on the server and the client side, and on the client side, JavaScript is a great way to do that. So again, just an example of JavaScript working on the front end to help prepare and process data. So the back end is where server-side operations take place. It's where data is stored, it's where it's managed, updated, permissions and accesses to data are managed. And it's the job of the back end to send data to and retrieve it from users. Now, there are a number of frameworks to aid you in this endeavor, and frameworks are basically just groups of a group of software and techniques that are used to build and deploy server-side applications or interfaces. And one such framework, for instance, is Ruby on Rails. And it comes with, like a lot of frameworks, a number of key features. One of those, just as an example, is automated emails. So for instance, if you wanted to send an automated email to a user confirming their registration, a framework like Ruby on Rails offers built-in solutions as opposed to just kind of building that from scratch. These are done in or with a scripting language like PHP. PHP scripts are executed on the server to update, process, and prepare data to be sent to the user. So there are a number of key aspects to consider when it comes to server-client systems. One of those, of course, being security. Again, it gives you centralized management, but also a single point of failure. To help combat that, you've got redundancy. That's where you can improve the resiliency and security of your data system by providing backup resources in the event of a critical failure. Something for consideration as well is scalability, having resources to be able to expand those capabilities during peak demand. To help effectuate all of this, you've got processing that takes place on the front end that can be controlled with client-side scripting like JavaScript, and you've also got back-end data processing. This is again on the server side, and that's controlled with frameworks like Ruby on Rails or server-side scripting languages like PHP.